Okay, so we're doing the 2-5 homework. It's up there, it's good. Okay, the first set of questions. Does the function have 1, 2, or no x-intercepts? Let's see, okay? I like to make a quick little sketch. What I have here is vertex form, okay? What's the vertex? Okay, this is vertex form. That's vertex form. So looking at it, let's match them up. That part is that part. And then it appears, oh, no, that was a bad idea. It appears that the k is missing. The only number that could be there, but they don't show me when I'm adding, because I'm adding k, is 0. So this is totally vertex form. Look at it. There's the plus k, there's the plus k. So now what's the vertex? Well, it's the opposite of this, not the opposite of this. There's the vertex. And then I go to the vertex, because remember, the key to x-intercepts, figuring out how many, is the location and the direction of the parabola. By location, I mean where's the vertex? And by direction, I mean does it open up or down? 1, 2, 3, 4, 5, 0 is the vertex. Ooh. When the vertex is on the x-axis, it doesn't matter if it opens up or down. No matter what, I'm only gonna cross the x-axis once. The answer is 1. Okay, next one. This one. Let's take a look again, all right? I need the location, which is the vertex. The vertex is the opposite of this, not the opposite of this. Which puts my vertex right around there. Okay, but now, depending on the direction, that really matters now. That's why this is there. Because look, if this opens up, I don't have any x-intercepts. But if it opens down, I got 2 x-intercepts. I need to know which it is. I need to know the direction. Where do I look to get the direction? You look right after that equal sign. If it's not negative, it opens up. If it is negative, it opens down. And this one is not negative, it opens up. So we've got this situation, which means we have no x-intercepts. Any questions? Or is it so far so good? It's good? Yeah? Yeah?
Is it always that when there's a negative, it's always just going to go down?
Yes. If after your equal sign there's a negative, like there is right there, and like there is right there, and right there, those were all parabolas that opened down. And it's in any form. Vertex form, standard form, factored form. You always look immediately after the equal sign. And if it's a negative, it opens down. Okay, so now, in this one, I already got the direction because we just talked about it. So this one opens down. But first, I do need the location. The location is the vertex, which is the opposite of this, not the opposite of this. And then that puts the vertex about where it was before. It was 5, 3 before also. But now I'm opening downward. Right there, 2. Yeah.
So if it's not negative, it goes up.
Wait. If it's not negative, it goes up. Yes. 100%. Yes. Sorry. I thought there was more to the question. Okay. Yeah, you guys, it's that simple. It really is that simple. If right after the equal sign there's a negative, that opens down. If there isn't, it opens up. Okay. So now that we have been able to identify how many, let's see if we can find them. Number 4. There's a sign on my board in my class. It says, looking for x-intercepts. Plug in 0 for y. You guys, I don't care what your function is. I don't care if it's a line or a circle, a parabola. I don't care if it's a sine graph, a cosine. I don't care what it is. If you're looking for x-intercepts, y's got to be 0. So you plug in 0 for y. Okay? Let's go see what happens. J of x is y. So 0 equals negative x minus 3 squared plus 4. And then you guys, our target is x. We want to solve for x. We zero in on our target from as far away as possible. We eliminate all the threat along the way, and then we get to our target. So the furthest away thing that I need to focus on first is this plus 4. Okay? Okay, so we do minus 4 on both sides to get rid of the plus 4. And I get that. And now, the next thing furthest away is the negative. This guy. So it was this guy. Now he's gone. Now it's that guy. The way I get rid of that negative is being multiplied. So I must divide it. If you don't see the number when it's multiplication, it's a 1. So that's a negative 1. And then I'm left with that. Okay. Let's take this party over here so I have more space to keep writing. I do the 4 equals x minus 3 squared. And now the thing furthest away I got to get rid of is the square. Luckily, they created something in math to get rid of it. It's a square root. But something crazy happens when we do it to two sides of an equation. A plus or minus. Make sure you write it down, that you don't forget it later. Okay, so square root of 4, that's 2. Technically it's 2 and negative 2, but because I wrote my plus or minus, I'm covered. I did them both, okay? And then on this side, the square root gets rid of the square, and I'm left with x minus 3. You guys do not add 3 to both sides right now. Don't do it. It's wrong. All right? The answer is not x equals plus or minus 5. This is bad. Instead, we have to recognize that this guy right here is 2 equations. It is positive 2 equals x minus 3. It's also negative 2 equals x minus 3. So write them, separate them. Now you can add the 3 to both sides in both equations to get our two x-intercepts. They are 5 and they are 1. Looking like this, x equals 5, x equals 1, these guys are solutions to our equation. When they want x-intercepts, we have to be able to convert this to ordered pairs. That means I want parentheses. That means I want a comma in the middle. That means I want my x values in the first spot. And that means I need a y value. Ooh, what is it? Oh my God, I don't remember what y is. What was y? It was 0. Remember? That's how this all came to be. X-intercept. Boom, done. Okay? We're gonna do it again. Ah. There we go. Okay. Okay. Do you guys want to do a different problem first? This one looks pretty good. Yeah. Number 7. Okay, so we're going to do number 7 in this video and then catch the rest of it in the next video. Okay. Which function has x-intercepts at this and this? You guys, there's a couple ways you could do it. You could find all of these guys as x-intercepts. See which ones are those. The other thing you might do is try to work backwards. All right? So this is like a 2 plus or minus rad 5 situation. If I work backwards, that means I had get the 2, move the 2 over. That means I had plus or minus rad 5 equals x minus 2. And then what was it that caused this plus or minus square root business? It was when I square rooted both sides. That's how that came. So to undo it now, I would square both sides. And then the square and the square root still cancel each other out even when it's in the opposite order. So this is now 5 equals x minus 2 squared. And now to turn it back into the quadratic equation that it was, move the 5 over. Because remember, we find x-intercepts when the y is 0. And now replace the 0 with y. That's one way to do it. It's probably the easier way to do it, maybe the less intuitive way to do it, but it definitely is better than the alternatives, okay? Or if you prefer, it's multiple choice, you can go back, solve each of these. It's great practice, yeah, but it's C.